Okay, we have officially reached the end of chemistry. So this is the last little bit of acid-base chemistry and our last actual section for chemistry due to time constraints. So we are talking about salts. So salts are super significant. They are found naturally in a ton of different places. There are different things we refer to as a salt chemically. So generally in our everyday life, when we are talking about salt, we're talking about table salt, which is sodium chloride. But there are actually a ton of different types of salt. So we're going to get into that in a bit more detail. So salts. Salts are ionic compounds formed when acids and bases react. Salts are also produced when oxides or carbonates react with acids or when metals react with acids. So don't stress too much about the terms oxides or carbonates. It's more just knowing that a salt is produced when these react with an acid. Table salt, NaCl, is found in seawater, sea lakes, or rock deposits. So the right image shows an example of the water cycle, which results in dissolved salts that do not evaporate from the ocean. Okay, so it's left behind essentially when water evaporates. And then also through erosion, it can be exposed from rocks because rainwater tends to be slightly acidic. Salt was once very valuable as a commodity. It's still really important in our everyday life, but in the past it was used to preserve food. It's used for medical reasons, etc. So our salt is no longer just sodium chloride. If you look, it's commonly called iodinized salt. So this basically means that iodine was added to the salt to minimize a disease called, or it's a symptom of the disease of the thyroid called a goiter, which is essentially swelling in your neck. Sodium chloride, NaCl, is only one kind of salt. A salt is made up of a positive ion from a base and a negative ion from an acid. So what does that look like? So a salt is made up of a positive ion from a base and a negative ion from an acid, remembering that the hydrogen and hydroxide ions form the water. So it's basically the two other ions that form the salt. So any ionic compound is potentially a salt, but it's only a salt based on how it was formed. So it needs to be in an acid-base reaction in order to be a salt. So we talked about sodium chloride and how ionic compounds form crystal lattice structures. So this is just an image of that again. So table salt forms a crystal lattice. That standard ionic structure where they have alternating positive and negative ions, but no actual bonds are being made. So you can see here, sodium is basically attracting these four chlorides based on the charge as it has lost an electron to chlorine, which has gained one, so opposite charges attract. So no bonds are made because no electrons are being shared. So no electrons are being shared, they aren't connected to specific ions. So when sodium chloride goes into water, it does dissolve into its components. So we get positive sodium ions and negative chloride ions. Salts are found in many things. So for example, in batteries, explosives, and fertilizers, and in multivitamins and in many living things. So how it works. Essentially, we have an acid plus base yields or produces salt plus water. So this is not new. This is your neutralization reaction, specifically when an acid reacts with a base. So now, instead of looking at the reaction overall, we're just focusing on the salt. So our acids always start with HA, and our bases always end in OH. This obviously forms water as well as a salt, HOH. So basically if I look here, I'm going to label these in different colors. So my hydrogen pairs up with my OH to form this HOH, which is just H2O. The nonmetal from the acid, the negative ion from the acid pairs with, so the nonmetal from the acid, which is the negative ion, pairs up with the metal ion from the base, so that's positive, forming this Ma. Okay, so that is how that process works. So anytime we have a salt, it is the metal from the base paired with the nonmetal from the acid. So that specific type of ionic compound, because it's still a metal and nonmetal, that is formed from this acid-base neutralization reaction is what we need in order for this to be considered a salt. Otherwise, it's just an ionic compound. Okay, and that is officially it for this section. Please follow through the schedule.